Okay, let's go again and dive straight into it. So I said I was going to explain the 0 degrees. Okay, remember that these aren't numbers; these are degrees. So these are angles. Okay, always got to bear in mind. Some people they look at the sort of sine, cos, and tan and don't realise that we are talking about angles. So you've got to bear that in mind. So I'll show you, how we find out that is indeed 0. Let's scroll down. So the logic is this. I mean, it's quite. It just makes perfect sense when you get down to it. So imagine, imagine if you did have a triangle. I'm going to just draw some rough triangles here. So imagine if you had a triangle like that, and just say that was, I don't know, 30 degrees, and then the angle kind of the triangle went to, I don't know, say 25, and just say that the angle got less and less. I'm just trying to illustrate that it's counterintuitive to say that you can have an angle of 0 degrees, but this is what I'm getting at. So just say it's an angle of 5 degrees, and then 4, 3, 2, and then you end up, this is why I'd never thought of it, the fact that you can have an angle of 0 degrees, because you haven't got an angle by definition. Okay, so so I don't think I would have ever made this sort of leap in logic, but someone did, and it was very helpful. So that's still not good enough for me. Oh, high standards. So I just see that as a line, right? But as I've just illustrated here, we're going down, 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 down to 0 degrees. Okay, so that makes an angle of 0 degrees, and the idea is that so that's the hypotenuse. We know that's the opposite, and that's the adjacent. So if you were to do the same thing here, so that just say that the angle was there. So that's the opposite, that angle, and this is the adjacent, and this is the hypotenuse. And so if you work through the trig, let's just go for blue. So let's just do it. So let's just do sine 0 degrees equals. Let's go back. So still not second nature there. Right. So opposite, right, which is 0, over the hypotenuse, which is let's just call the hypotenuse h for now. So what's 0? So I mean, this is where it becomes slightly, what is 0 divided by the hypotenuse? If we what's 0 divided by 2? Can you do 0 divided by 2? I mean, if you plug it in your calculator, let's go and get the calculator and show you and see what the calculator comes up with. Go. Calculator. Okay, so 0 divided by 2, sorry for the burp, is 0. That's what the calculator gives. And I will in another video show you, perhaps, or I will do, why 0 divided by 2 is 0. So it kind of doesn't matter. I mean, I could have arbitrarily, just made this length 1 or 2 or 3 or 100 million. It doesn't matter. 0 divided by 100 million, billion, zillion equals 0. And that's why sine of 0 is 0. So if you want to fill that in, so I've used y already, or done it already. There you go, 0. So let's do cos of 0, and let's go for a nice pink. So cos 0 equals, let's just remind ourselves, adjacent over hypotenuse. Well, if we have a look here, the adjacent and the hypotenuse are exactly the same length. So, we could pick any number, make it 1 or 2 or 100 billion divided by 100 billion. Let's just pick 1 for now. 1 divided by 1 equals 1, right? So there you go. We could have made it 10. 10 divided by 1 is 1. So cos of 0 equals 1. So let's go and chuck that in as well. Cos 0 equals 1. Which is I just find that fascinating personally. It buzzes me, and is as much as I'm not that good at sort of coming out with these things, I'd never come out with these things in a million years. But uh, I'm fascinated, in understanding. You look at that, you see it, and it just dazzles you, and you just want to understand it. So let's go for tan. Let's go for tan. I like that colour, but so disappointing that I have to change it. Well, I don't have to, but it just makes it nice and clear. Right, so tan. And what was tan? So tan was toa. So it's opposite over the adjacent. So the opposite is 0. And the adjacent is, in this instance, it's 1. But once again, if we chose any number, think of a number, 11 or 110 or 1100 or 21,100, doesn't matter. 0 divided by any number always equals 0. So tan 0 is also 0. And there are further identifications to be made. You might start to see that certain things equal certain things on this thing. Okay, so, let's have a look at sine 45. Sine 45 equals cos 45, and you can go away and investigate what that means. I'll just sort of get you going. But we said that cos 45, we've worked it out, sine 45. So that's very interesting. So what if you had cos theta? You didn't know the angle of theta, but you knew the angle of sine. So if you want to take that across, theta equals cos sine 45. You know what theta is, but we know that, no, that's all crap. That's all bollocks. So sine 45 equals sine 45. So, well, I'll cut this out. Video, cut that. So there we go. We filled in sine, cos, and tan for the 0 degrees angle, and the last one to do is 90 degrees. What I might do in the next video is also try, well, not try, I will show you why 0, or prove to you why is it. No, I won't. I'll do that in another video. Back to it. So there we have our sine, cos, and tan of 0 degrees. So as you can see, sine 0 equals 0, tan 0 equals 0, and there are special things that you can kind of do knowing that sine 0 equals tan 0, and you also have other things. If you have a look, I'll try and illustrate this with a better colour. Right, so sine, that's a match, and that's a match, right? So, sine 0 equals 0, tan 0 equals 0. I'll do this in another video. Take 5. So there we have it, sine, cos, tan of 0 degrees, and in the next video I'm going to show you how we fill in the sine, cos, and tan of 90 degrees, and it's all very exciting. The climax of this mini series of trigonometric identities, and we'll see you in the next video.